Aquaponics refers to any system that combines conventional aquaculture, raising aquatic animals such as snails, fish, crayfish or prawns in tanks, with hydroponics, cultivating plants in water in a symbiotic environment. In normal aquaculture, excretions from the animals being raised can accumulate in the water, increasing toxicity. In an aquaponic system, water from an aquaculture system is fed to a hydroponic system where the byproducts are broken down by nitrifying bacteria initially into nitrites and subsequently into nitrates that are utilized by the plants as nutrients. Then, the water is recirculated back to the aquaculture system. As existing hydroponic and aquaculture farming techniques form the basis for all aquaponic systems, the size, complexity, and types of foods grown in an aquaponic system can vary as much as any system found in either distinct farming discipline. Bacteria. Nitrification, the aerobic conversion of ammonia into nitrates, is one of the most important functions in an aquaponic system as it reduces the toxicity of the water for fish, and allows the resulting nitrate compounds to be removed by the plants for nourishment. Ammonia is steadily released into the water through the excreta and gills of fish as a product of their metabolism, but must be filtered out of the water since higher concentrations of ammonia, commonly between 0.5 and 1 ppm, can impair growth, cause widespread damage to tissues, decrease resistance to disease and even kill the fish. Although plants can absorb ammonia from the water to some degree, nitrates are assimilated more easily, thereby efficiently reducing the toxicity of the water for fish. Ammonia can be converted into safer nitrogenous compounds through combined healthy populations of two types of bacteria, nitrosomonas which convert ammonia into nitrites, and nitrobacter which then convert nitrites into nitrates. While nitrate is still harmful to fish due to its ability to create metahemoglobin, which cannot bind oxygen, by attaching to hemoglobin, nitrates are able to be tolerated at high levels by fish. High surface area provides more space for the growth of nitrifying bacteria. Grow bed material choices require careful analysis of the surface area, price and maintainability considerations. Hydroponic subsystem. Plants are grown as in hydroponics systems, with their roots immersed in the nutrient-rich effluent water. This enables them to filter out the ammonia that is toxic to the aquatic animals, or its metabolites. After the water has passed through the hydroponic subsystem, it is cleaned and oxygenated, and can return to the aquaculture vessels. This cycle is continuous. Common aquaponic applications of hydroponic systems include deep water raft aquaponics, styrofoam rafts floating in a relatively deep aquaculture basin in troughs. Raft tanks can be constructed to be quite large, and enable seedlings to be transplanted at one end of the tank while fully grown plants are harvested at the other, thus ensuring optimal floor space usage. Recirculating aquaponics, solid media such as gravel or clay beads, held in a container that is flooded with water from the aquaculture. This type of aquaponics is also known as closed-loop aquaponics. Reciprocating aquaponics, solid media in a container that is alternately flooded and drained utilizing different types of siphon drains. This type of aquaponics is also known as flood and drain aquaponics or ebb and flow aquaponics. Nutrient film technique channels. Plants are grown in lengthy narrow channels, with a film of nutrient-filled water constantly flowing past the plant roots. Due to the small amount of water and narrow channels, helpful bacteria cannot live there and therefore a biofilter is required for this method. Other systems use towers that are trickle-fed from the top, horizontal PVC pipes with holes for the pots, plastic barrels cut in half with gravel or rafts in them. Each approach has its own benefits, since plants at different growth stages require different amounts of minerals and nutrients. Plant harvesting is staggered with seedlings growing at the same time as mature plants.